JavaScript. Today JavaScript is the most widely used and arguably the most famous programming language we have. But do we know how its internal work? How the call stack, event loop and task and microtask work and together make JavaScript runtime? So today in iCoding Club we're going to demystify that part and try to understand how JavaScript actually work under the hood. Before we jump to the internals of JavaScript, let's start with a simple question. Can we see the code right now and just try to figure out what it will print? What will be the output? Take a pause here and try to understand what it will print. All right. Let's start. If you're new to JavaScript or you came from a Java background or C++ background and you are used to running everything sequentially, you might think that we will start from line number 1, it will print start, it will keep going, C is some of the function and some of the other things, and then when the bar get called it will come to line number 9, see the set timeout which get resolved in just 0 microsecond, and it will print timer, and then it will come to the foo and it will print promise, and at the end it will print end, something like this, right? Just sequential order. Definitely JavaScript doesn't work in this way. JavaScript is asynchronous language, so this answer is wrong. But if you understand how JavaScript work, how the whole event loop system work, you might think that it will print start, end, timer and promise. How come? It will come from the start, then it goes to the line number 13, enter to the bar, and then see there is a set timeout, so it will put the timer into the call stack, then go to the foo, and there it see there is a promise which just resolve immediately, so it will put promise into the call stack, and come back here and print 14, line number 14, that is the end. Once both are done, then it will start pulling from the call stack, and since it put the timer first, it will print timer, and then it will print promise because it was last in the call stack, and that result into start, end, timer and promise. But my friend, this is also wrong. The right answer here is that it will print start, end, promise and timer. So even though the promise has been put later in the call stack, it will be called before timer. And in this video we basically going to understand that how this whole code result into this output, and how the whole JavaScript runtime kind of summarize in this particular 14 lines of code. We have everything what we need to understand in this 14 line of code, that is the concept of single-threaded JavaScript, the concept of stack, the concept of task, the concept of microtask, and together it's all make JavaScript runtime. And in case you guys are wondering, no, it was not a simple question. It is actually a little bit tough, and you need the complete understanding of JavaScript runtime to kind of answer this question. So let's start with single-threaded JavaScript concept. Now JavaScript, people say, and it documented that it is a single-threaded, but it is difficult to understand or difficult to visualize, because if you are filling a form on a website, right, while you are filling the form and click on submit, we are doing the communication with the server, and some communication with server is happening in the background. It can happen multiple times. It may validate some of the input what you have entered in the form, try to upload the picture you just uploaded, and while everything is happening, interestingly, sometimes we see there's some kind of notification come on the page, sometime a pop-up come, or sometimes some error get thrown. So really multiple tasks is happening in the background. Then how come it is a single threaded language? And that result into this question, that is JavaScript really a single threaded? Turn out that multi-threaded and the multitasking are two different things. JavaScript indeed a single threaded language, but it's JavaScript runtime which make the multitasking possible. So let's see how the whole thing work together. So we'll first start with the concept of stack. Now remember the question I asked you guys? Let's go back to that question. Take out the promise and the set timeout part of it and try to understand just the synchronous code inside of it. Now it's much more simpler version. Let's see how it's actually work. So you come from the line number 1. As soon you come on the line number 1, JavaScript print start, because it's a console log statement. Then it come to the line number 3 to 5, but it is just a function declaration, so just skip it. Register the function that okay, we have a function called foo, but we don't have to run anything right now. Then it come to line number 7 to 10, see another function there. It registered that as well, but doesn't execute it. And only at the line number 12, it see there is finally something to run. And as soon JavaScript come to line number 12 and execute the bar, the stack come into the stack come in live, and it put the bar as the first element over the stack. We enter into the bar function. We see that there is a console log, so that should get printed next. And once that get printed, we come to line number 9 where we see there is another function. So we are calling foo inside of bar. But bar is yet not over. So once we call the foo, it gets stacked up over the bar, and then we have the foo at the top. Once we commit the foo at line number 3, move further on line number 4, we see another log statement. So that gets printed and foo goes on the terminal. After that, we see there is nothing much, is a close curly braces, no another function call, so we just come back from there. And by moment we exit from the foo method, the foo get removed from the stack as well. We come to line number 9, which is from where we call the foo, but it's also a return statement. So after they're done with the line number 9, the bar will also goes away from the stack. And we back to line number 12, and then JavaScript move further on the line number 13 where it see there is a console log. So it will just print the last log statement. Simple so far. This is the way JavaScript works. This is the way most of the programming language and their function call work. So nothing special about here. Now let's understand that how the event loop and task queue work, which actually responsible for whole multitasking in JavaScript. So let's start with the previous example and change the code a little bit and try to put a set timeout in both the method. So we will have a first set timeout in the bar on the line number 10. We will call this in the timeout, we will call a callback in 100 millisecond, and we will just print something called timeout in the bar. For meanwhile, we will call a bar callback or bar CB, and then we have another timeout here in line number 5 which will do the same exact thing but print timeout in foo, and we will call it foo callback in our example. So let's see how it works. Again, we will start from the line number 1. We'll go to the console.log. It will print the start, so same as so far, and then it will reach to the line number 14, put the bar in the stack, same as last time, and inside of bar on the line number 10 it encounter the set timeout. Now set timeout is another function, so it will call the set timeout. But then JavaScript knows that set timeout is a special function, and that function, and with that function we introduce something called web APIs. Now JavaScript runtime interact with the browser or the node web APIs, or in this context we will call web API, where we can have the special function around the timer, the event management, and the fetch. In the discussion we will focus our attention toward the timer function, and we'll see that how the timer works in the web APIs. So let's resume our code call. So in the line number 10, JavaScript found that there is a set timeout and there is a callback in the 100 millisecond. So what it do is like, okay, set timeout belongs to web API. So let me just pass this to the web APIs, and then it will just transfer that to the whole web API system. What web API will do, it will actually, take an entry of it and note down that there is a timer 1, which is supposed to be called in 100 millisecond. And when 100 millisecond is passed, I supposed to call bar callback. With that, the job of set timeout is over. So let's take out from the callback from the stack. Let's move further, and we'll go to the line number 11. Please note at this time that the callback is in the browser or in the web APIs part, right? It's not been executed yet. Right, so the normal execution of JavaScript will continue here, and it will reach to line number 11, where it see there is a foo. So it will go inside the foo function. They see there is another set timeout. So another same set of event will be repeated. So we will get the foo in the stack, and then we'll get a set timeout. Set time we have another callback, so it will get registered in the whole web API system. And with this, the job of set time is also over. So it will taken out from the stack. And after this line, the whole foo is also, the job of the foo is also over. So that will also taken out from the stack. We will come back to the bar, and we also on the line number 11, which is the end of the bar. So the bar will be also taken out from the whole call stack. We'll back to the line number 14. And then line number 15, which will result into a console out of end. With that, the whole synchronous call is over, and now all eyes are on the web APIs. So while we are cleaning up the whole stack, web APIs was not sitting idly. It was actually processing those timer, and in this case just waiting for 100 millisecond, but it can be very complex in other cases. And while this whole thing is happening, right, it just kind of wait, and once this whole thing is over, the whole the required operation is over. In that case, it is ready for hand over the bar callback and the full callback back to the JavaScript runtime. But how can it do it? It cannot pass it directly to the stack, so it requires two more actors in this whole story, which will help with the passing this callback back to the stack. And those two actors are actually responsible for the whole multitasking in JavaScript. So the first actor is task queue, and the second actor is event loop. Together they make the whole multitasking possible. Let's see how that works. So we know that the bar callback and the foo callback are ready to come to be executed or to run by the JavaScript. So what browser does, or web API does, it passes those bar callback and foo callback to the task queue. And there they just kind of queue up and ready to be passed back to the stack. With that, the the part of web API is over, and then the whole part of event loop come into picture. Now event loop just doesn't, since it is because they're in the task queue, it doesn't put it back directly to the stack. It first check that do we have something in the stack. If we have something in stack, it wait for that something to be executed and comes out from the stack. And only when it knows that the whole stack is clean, then it's actually give a green signal for the whole bar callback and foo callback to go back to the to go in the stack. And the first bar callback will go, it will get executed with JavaScript, and that will print to timeout in the bar, which is the result of the callback. Once that operation is done, it's out of the stack, and then now the part of foo callback come into picture, and then same way the foo callback will also enter into stack. Once it get executed, it will print timeout in foo. And this is the way the whole the multitasking and the call, the task queue event loop actually work. But is it the end of the story? No, we have one last thing we need to understand, that is the micro task concept. Let's see how the micro task come into picture and how it is different than the task which we have seen in the last part of the video. Let's start back from the code we had, and where we put the timeout, set timeout, and in the both the function we put the set timeout. Now imagine that in foo, in place of set timeout, we put a promise. So how JavaScript handle this third type of factor differently? Well, to start with, the browser or the web APIs need to handle it differently. It's not a timer, it's a promise. So let's do adjustment for that. Now the web API has two parts here. One is timer and second is the promise. And then again, just like timer, it will keep an index that when the promise is resolved, I need to call the foo callback. But at this time, there is an entry of another actor in the whole story, and that is the micro task queue. How it actually work? Yes, we will come back to this. But let's continue in the execution. So we have a timer and we have the promise, and now the time is to pass it back to the tasks, to the queues for JavaScript to execute it. We'll start with the timer, bar callback. Just like previous time, it will go to the bar callback in the task queue. Now it's a time of promise, and the foo callback is also ready. But in place of going to the task queue, it go to the micro task queue. And here the whole story differ. Well, the bar callback, where the task queue is basically meant to handle the task. So what are the type of tasks we have? So let's say a new program run, all called by script tag. All those are a normal task. Those come into the task queue. A event callback, when you click on button, these are also tasks. So it will come to the task queue. And what we have seen so far, that the result of timer function, that is set timeout or set interval, all those go into task queue. But the micro task queue is different and dedicated for two type of task. One, the result of promise, and second is something called queue micro task. If you call anything from the queue micro task, all those will go into the micro task queue. And we will come back to that later. Let's continue with our execution and see that how things are working. So now our whole micro task queue and the task queues both are ready to push back their respective tasks to the stack, and we are good. We have the green signal here. But in place of task queue, the micro task queue get a preference here, and that's the difference here. Micro tasks always get preference, and not only once. All the tasks in the micro task will get executed first before we go to the task queue. So even though we have XYZ callback in the micro task, all will be get executed first before the bar callback get called. And that's how the micro task queue work. It's more like a priority queue in the JavaScript system. And JavaScript made it to handle special cases like a promise and queue micro task, where the initial code and the callback result of it are kind of related, right? If you see the promise, what it get resolved and what data it pass, those get called into the callback. Those get worked on the callbacks. But the event callbacks are different. Those are in the work as a isolated events or isolated task, right? So that's the way JavaScript handle it. The whole mechanism is different, and we will talk about those in more detail in the next part. But let's continue with the execution. So now our foo callback is already in the stack, and that it will get called first, and that will result into printing micro task in the queue. And now the last part, that is the bar callback. So bar callback event loop will see that okay, I don't have anything pending in the micro task queue. So let's see if there is anything in the task queue. So it take the bar callback, put it into the stack, and that will result, executing it will result into timeout in the bar. And this is the way the whole things actually work. And together the whole part make the JavaScript runtime. With the concept of the stack, the queue, the microtask queue, and with the whole web APIs, now you are the graduate on the JavaScript runtime. This is all what you need to know. The one last thing before we wrap up is to understand the queue microtask. Now, queue microtask is a special function exposed by the browser to handle the related asynchronous operation. What I meant by that, if you see the promise chaining, there are multiple thens, and all the method inside then, all those callbacks are asynchronous. They work in independent to each other, but they need to have a sequence, and that's very important for the whole promise to work properly. Now this one is pretty deep topic, so what I have done is I have created one dedicated video around it to understand how the whole JavaScript promise works. In this, I implemented the JavaScript promise from the scratch, and there we I introduced the concept of queue microtask and try to explain the whole thing in detail. So definitely, if you want to solidify your understanding, definitely go and check out this particular video. That will fill the last gap you have in the whole in understanding the whole JavaScript runtime system. Alright folks, so that's all I wanted to cover. In case you like the content of this particular video, please like the video and subscribe the channel. And in case you have any question, please provide that in the comment section, and I will see you in the next video. Thank you.